Hey guys, welcome back. I'm Mr. Silverstein, and today we're going to get into working with the properties of water. I'm going to share my screen and we'll get ourselves started. So we're moving into part 2 of concept 2 of the chemistry of life, dealing with the properties of water. And our objective is for you to be able to explain the chemical and physical properties of water that make it such a unique molecule. Now, as you recall, when I introduced myself to you early in the semester, I told you that I've spent about 30 years under the water. So before we start getting into all of this sciencey, chemistry, molecule-y stuff, let's go and take a look at what life looks like under the sea. Just a little relaxation with a conch shell down in the Cayman Islands. All right, so we're going to get into the properties of water. This is your concept 2 notes, part 2. And this is kind of heavy notes. It'll take you a little while. We're going to chunk through this. So work through it carefully. And remember, these slides are posted for you. Let's talk about water. Yesterday, we were talking about elements and bonding and why elements like to bond to become stable. Now, water is 1 atom of oxygen and 2 atoms of hydrogen held together by a covalent bond, and together they become H2O, or 2 hydrogens, 1 oxygen. When you look at this water molecule, you'll see the shape of it is showing these positively charged hydrogens and the negatively charged oxygen. When they come together, they form this interesting bond. Water is a polar molecule, which means that there's an unequal distribution of the charges. You'll see one side is more charged than the other. One side is more positive. The hydrogen side is positive and the oxygen side is negative. What that means is when the water molecules are close together, their opposite sides are attracted to each other because of polarity. That's how you can actually put your finger into a glass of water, because you're moving apart those water molecules and you separate them out, and then they're attracted back to each other. So when water molecules are close, their opposite sides are attracted to each other because of polarity. This attraction between water molecules is responsible for most of the properties of water, which is what makes water such an incredibly unique molecule. let's talk about polar and nonpolar molecules. A polar molecule is the unequal distribution of charges. One side is more positive, one side is more negative. Polar molecules can dissolve in water. Nonpolar molecules, there's no separation of charge, so there's no positive or negative poles are formed. They do not dissolve in water. Common nonpolar molecules are things like carbon dioxide gas. It will not dissolve in water. Oxygen, O2, will not dissolve in water. And lipids or fats do not dissolve in water. And that's how you will find the expression water and oil do not mix. Well, oils are lipids, and they don't dissolve in water at all. So we have polar molecules that will dissolve in water and nonpolar molecules that will not dissolve in water. Now, polar molecules can be attracted to each other, polar water molecules. The partially positive hydrogen atom is attracted to the partially negative oxygen atom of a different water molecule. And this attraction is what we call a hydrogen bond. And so if we look at these three water molecules in the lower right-hand side of the screen, you'll see the little H and the big O and that little dotted line between them. That is what we're going to call the hydrogen bond. And that hydrogen bond is actually fairly weak. The stronger bond that actually holds the molecule together internally, that's that covalent bond. So when the water molecule is by itself, you've got the oxygen and two hydrogens, and they're very strongly held together, the hydrogen and the oxygen. But when one water molecule snuggles up next to another water molecule, what's holding those two molecules together is this very weak hydrogen bond. You can break that bond very easily. Now, I want you to imagine going out to a swimming pool. When you go out to a swimming pool, if you ever have done a belly flop into the water, you fall into the water, all of you hits the water and smack, it hurts. Why? Because you don't break the hydrogen bonds. Because so much surface area of you hits so much surface area of the water, you didn't get a chance to break those bonds. But if you dive into the water, put your hands out in front of you, your fingertips break the water and break that hydrogen bond, and that water separates, all those molecules separate from each other. And then as you pass through it, those water molecules are attracted to each other again. And that's what's really cool about moving through the water. So it's those weaker hydrogen bonds that hold the different water molecules together externally. Now, the covalent bonds internally hold that water molecule together. And different water molecules are held together externally by very weak hydrogen bonds. So we have the covalent bond inside the molecule and the hydrogen bond outside the molecule. Covalent bonds inside, hydrogen bonds outside. Now, there's 5 characteristics of water, and we're going to go through each one of them today. There's cohesion, adhesion, high specific heat. Water is less dense as a solid, and water is a terrific solvent. So make sure you add these terms to your vocabulary section, and we'll go through each one of them as we move along. Let's talk about cohesion. This is a spider web. If you've ever seen a spider web early in the morning, as the moisture in the air forms, it hangs onto those little tiny threads of the spider web. And cohesion means together. Co means together. And so this is the attraction of the water molecules of the same substance. So these little water molecules are hanging on to a thread, but they're still attracted to each other with that hydrogen bond. This is essentially water sticking to water. And it's the tendency of molecules of the same kind to stick together. What this also causes is what's called high surface tension. And the lab that you're going to do today, when you're done with this lesson, is dealing with surface tension. And so we can measure, the measure of how difficult it is to stretch or break the resistance of a liquid is called surface tension. Let's talk about adhesion. Adhesion is where the type of attraction that happens between two different water molecules. So, adhesion is the different molecules, water attracted to glass or soil or plant tissue or cotton. If you've ever driven in a car while it's raining and you're looking out the window, you can see those little water droplets on the window hanging onto that glass as the car is moving along. And you'll see that they continue to move along, and that is adhesion. And adhesion forms stronger bonds than cohesion. Remember, cohesion is when that molecule is attracted to itself. Adhesion is between two different kinds of molecules. So, if we've ever looked at pouring liquids into a graduated cylinder, you've heard the term meniscus. The meniscus is where that water or that liquid slides up the side of the graduated cylinder. And we want to make sure we can actually look at the belly of that amount of water in that graduated cylinder to get a very accurate and precise measurement. The other thing with adhesion is the capillary action that's seen in plants and trees and with straws. The way a plant gets its water up into its roots, up into its stems, and up into its leaves is a capillary action. It starts to climb up because it's forming a bond. The third property of water that's really neat is known as high specific heat. The temperature of water does not change very easily. It takes an enormous amount of heat and cooling to change the temperature of water. Water has to absorb more heat energy to increase the overall temperature compared to other compounds. Now, what's nice about this is what helps regulate the cell temperatures in organisms. It's how many organisms can live in so many different environments, hot and cold, because water helps regulate the cell temperatures. Its temperature does not fluctuate very much, and it also allows life to live in water. Imagine if you lived in the water. It is that high specific heat of water that allows it to regulate the temperature. It buffers large fluctuations in the temperature, which keeps the Earth's climate moderate. We have polar caps, and then we have all the major oceans. Remember, 2/3 of the Earth is covered by water, and it's all of that water that helps regulate the temperature around the Earth. The other neat thing about water is it's less dense as a solid. That's why icebergs can float. Solid water or ice is less dense than liquid water. it actually floats in liquid water. And so you can also see this with your ice cubes, or a big block of ice can float on the water. And since ice floats in the water, life can exist under the frozen surfaces of lakes and polar seas. All kinds of things live underneath the ice. Water is also an incredibly terrific solvent. One term that you want to be familiar with is the term solution. It's a uniform mixture of two or more substances that get mixed together. Salt water is a solution. Lemonade is a solution. A solute, another term for you, is what actually gets dissolved. The solute is that lemonade powder or that sugar that goes into water. The solute is what gets dissolved. The solvent is what does the dissolving. So in this case, water is the solvent. Water's polarity makes it really good at dissolving things, and thus water is considered the universal solvent. It dissolves more substances than any other liquid. That's one of the reasons why we use water to wash our hands, because no matter what you get on your hands, you can pretty much wash it off with good water. Now, another thing about water, we need to talk about hydrophilic and hydrophobic substances, because this is really going to become important as we get into our macromolecules. A hydrophilic substance is a substance that has an affinity for water. It loves water. We consider it water loving. And it usually dissolves easily in water. For example, salt and sugar. Salt dissolves very easily in water, so does sugar. A hydrophobic substance does not have an affinity for water. It wants to repel the water and push it away. It's water-fearing, and it will not dissolve in water. And the great example of a hydrophobic substance is oil or lipids or fats. They will not dissolve in water. So let's summarize these properties of water. The water molecule is made up of one atom of oxygen and two atoms of hydrogen held together by covalent bonds, making H2O. Water has 5 unique properties: cohesion, adhesion, high specific heat, and is less dense as a solid and is an absolutely terrific solvent. Water helps regulate most organisms' temperatures, providing homeostasis. And we get into cell functions, you'll see where the homeostasis comes into play. Okay, I'm going to stop our share right now. And what we're going to do next is we're going to take a pause for a moment, and I'm going to change screens. Okay, I changed screens here. After you go back and go through your notes, you're going to work on your first water property activity. It's a lab. You're going to open up your next tab, and you're going to find this little water property activity. The goal here is for you to learn about surface tension. So you're going to watch a video demonstration. You're going to need a couple of supplies. You're going to need 2 cups or measuring cups to hold the water, 2 droppers or small straws, 2 clean pennies, some water, and some dish or liquid hand soap, and a spoon to mix the soap. You'll also need some paper towels and some things to clean up. What you're going to do is carefully with the water, you're going to see how many droplets of water can fit on the side of a penny. Once the water falls off, that's when you stop counting. You're going to repeat that for 5 trials. Then you're also going to do some drops of soapy water. You're going to put a little soap in the water, mix it together, and do the dropping again. You're going to enter your data on a data table that's attached to the assignment. You're also going to develop a data graph chart that's going to automatically populate for you when you add your data into the table. Then there are some reflection questions, also known as your lab report. And so make sure you do this carefully, and you'll have a good time doing this activity. If you have any questions about it, just message me back and we can see if we can help solve those. So other than that, you guys have been great this week. We covered a lot of material. Tomorrow, we'll recap our week during our morning session. You guys have a great day.